All right, let's continue working with quadratic equations. Today we're going to solve quadratic equations by factoring. Now remember, a solution of a quadratic equation is the x-intercepts, which will either have 2, 1, or none. So today we're going to do that using the zero product property, which means the product of two numbers, getting you to 0. We're going to use that on this first example here. Okay, so the zero property product tells us that for any real numbers, a and b, if a, b equals 0, then a would equal 0 or b will equal 0. Either one can be 0, okay, and that's true. So for an example, if x plus 3 times x plus 2 equals 0, then x plus 3 could equal 0 or x plus 2 equals 0. And we're going to use that concept to find our solution to our quadratic equation. So if that's true, then 4 times t plus 1 can equal 0, or t minus 2 can equal 0. And we can solve these out to solve for t. Solve this guy. So you can see that our two solutions are going to be negative 1/4 and 2 would be the two solutions to this quadratic equation. Now, I would like you to do this using the zero property to find the solution to these quadratic equations. So go ahead and press pause and work them out and see what you come up with. All right, take a look at your answers. I took the two binomials and broke them into the two parts and tried to find their solution using the zero property. So for the first one, my x-intercepts or my solution is negative 1/5. For the second one, it's negative 3/2, 4. For the third one, C, is negative 1/2, negative 14. And D, the fourth one, is 2/7 and 4/5. You can also use the zero property product to solve equations in the form of ax squared plus bx plus c equals 0. It's a quadratic expression, ax squared plus bx plus c, if it can be factored. So we're going to factor this first. Okay, so let's work on this guy. We're going to say x squared plus 8x plus 15 equals 0. Now remember, if we can break this into our two binomials, then that's where we can get some work done. And when I say get our work done, I'm like looking for the solution. So I'm asking myself what times what gets me 15, that when I add them together, I get 8. So I can see maybe 3 times 5 and 3 plus 5. 5, 6, 7, 8. 3 times 5 is 15. All right, so that looks like those are the factors I can use. So x plus 3 times x plus 5 equals 0. And then I can do x plus 3 equals 0 and x plus 5 equals 0. Minus 3 minus 5. And up with x equals a negative 3 and x equals a negative 5. So I'm looking for the solutions where the x-intercepts is negative 3 and negative 5. A would be my answer for this one. All right, why don't you go ahead and check out this next one here. Why don't you press pause and try this on yours. Now you'll have to factor these first and then find the solution. All right, so for A, I factored it out to m minus 7 and m plus 2, and I used the multiplication zero property, work those out to find out that it's negative 2, 7 are my solutions. So notice how I built these two. When I give my answer, I give my lowest answer first and the second answer, even though I solved this 7 first. And then the negative 2, when I write it, I write down negative 2 first. just one of those details. For the second one, did the same thing. I found negative 20 and then factored that all the way out to p plus 5, p minus 4, and I found my answer to be negative 5 and 4. For C was a little bit trickier. I had to go back to some of the stuff I've learned before. When there's an A term bigger than 1, I had to take my A term times my B term, and I ended up working with 36, factored that out to get negative 3 and negative 12, and it left me with 2a squared minus 3a minus 12a plus 18. I grouped those, factored each one of those. Something I had to keep an eye on though, and all that was how this negative plays out and everything. So I ended up with a minus 6 times 2a minus 3, and I zeroed out both of those, and to find that my solution is at 6 and 3 halves, and I would write that as 3 halves, not 3/4, 3 halves and 6, to do that in the best order. All right, let's look at the next concept here. Before solving a quadratic equation, you may need to add or subtract terms from each side in order to write the equation in standard form. Standard form being our ax squared plus bx plus c. And right now we have 18 over here. So we need to subtract 18 from both sides, so we can have 4x squared minus 21x minus 18 equals 0. This is going to need to be factored out. I'm going to be looking for what times what gets me to negative 18, and it's going to be 3 and negative 6. And this will be same thing, 3 plus negative 6. Hold on a second. I've totally skipped a few steps here, so hold on. All right, I don't know what I was thinking. I just can't do that. My A term is greater than 1. So I gotta do some math here. So in order to work this one out, I'm looking to see my A term and my C term. They're not perfect squares. They're not both prime numbers, so I can't use any of those special cases. So I have to do 4 times 18, and I get myself 72. And then I got to factor that out. So what times what gets me 72? That when added together gets me to negative 21. And I found that negative 24 and 3. Negative 24 times 3 gets me to 72. And negative 24 plus 3 gets me to that negative 21x. So that means I can have 4x squared and minus 24x plus 3x minus 18. I'm going to do some grouping here. I'm going to factor out my first group. I can factor out 4x out of that. End up with x minus 6. Plus I can factor a 3 out of that. I end up with x minus 6. That's good news. I like when I see that. So that's 4x plus 3. My first one. And my second term is going to be that x, or my second binomial. All right, once I have that, then I can use my 0 property. Minus 3, so 4x equals a negative 3, divide by 4, and then I end up with x equals a negative 3/4 for one of them. And my second one is x minus 6 equals 0, add 6 to both sides, and I get 6. So my solution to this is negative 3/4 or 6, and I can put an or next to it. Because I'm using my 0 term, I don't know which one of these is 0. I don't know if it's my first binomial or my second binomial. So I'm going to use or as I wrote or. It's one or the other. All right, why don't you go ahead and try it on this one. Remember, put it in standard form first. For this one, when I added 49 to both sides, I noticed that I had my A term and my C term, that they were perfect squares. And so I was able to write that as a perfect square. X plus 7, all of that squared. So that means that x plus 7 equals 0 gives me x equals negative 7 as my answer. And really it's my only answer because this is equal to x plus 7 times x plus 7. So if I run it both ways, this is going to still end up being x equals negative 7, and this is going to end up being x equals negative 7. So this one actually has only one solution, x equals negative 7. All right, I am going to go make a salad using only my feet. Gross me out.